We're starting Chapter 4, Part B. In this segment, we're going to move on to annuities, both ordinary and annuities due, as well as perpetuities and uneven cash flows. As you'll recall, an annuity is a series of equal payments occurring at equal intervals for a finite period of time. Most annuities are termed ordinary annuities, meaning the cash flows occur at the end of the periods. With an annuity due, all payments occur at the beginning of each period. That's the only difference. To find the future value of an annuity, we could simply future value each cash flow to the end and add them up. It works, but it's a bit laborious. There's an algebraic formula for the future value of an annuity shown on the slide. To enter this in your calculator, here are the steps. 1.10 y to the x 3 equals minus 1 equals divided by 0.10 equals times 100 equals 331. Your calculator solves the equation shown on this slide. We're using the TVM keys, but now adding the payment key. 5 variables, enter any 4, and solve for the 5th. Here is our 3-year $100 annuity solved for the future value. Note that the $100 is entered as a negative to indicate that you're depositing the money in an account that is earning 10% a year. In Excel, we use the same future value function we saw in Part A, but now the payment variable is not 0. For the present value of an annuity, we could take the same approach as with the future value. Discount each cash flow individually back to time 0 and add them up. Again, it's laborious. Here's the full formula for the present value of an ordinary annuity. Same answer we get by discounting and summing each cash flow. But by far the easiest way is to use the TVM keys on your calculator. This solution implies that if you deposit $248.69 in an account paying 10% a year, you can withdraw $100 each year for 3 years until the account is depleted to 0. As before, use the PV function, now including the payment variable. Those we've looked at so far were ordinary annuities, with the cash flows occurring at the end of the periods. If the cash flows occur at the beginning, it's an annuity due, as shown above on the timeline. In the case of both the present value and future value of annuities due, their value is simply the value of the corresponding ordinary annuity times 1 plus the interest rate. As we'll see on the following slides, you can achieve the same result by changing the default from end to begin, computing using the TVM keys, but then you have to remember to go back to end. Using the technique on this slide is far safer. This demonstrates using begin mode. The values in the TVM keys are entered in the same way as for an ordinary annuity, and for the future value of an annuity due. In Excel, you do have to make an explicit entry to tell Excel the annuity is an annuity due. Note the final variable in both the PV and FV functions. The default value for this variable is 0, and you do not have to enter it. But if it's an annuity due, you must enter a 1 in this field. The type of situation we're more likely to encounter is one of an uneven cash flow stream where the values differ period to period. As with the previous examples, we can simply discount each individual cash flow, using the formula or the TVM keys, and add them up. It's not a problem if it's a short stream. Fortunately, the TI Business Analyst 2 has a built-in cash flow worksheet, accessed by pressing the CF key. It's right below Enter. In this case, you do need to clear the worksheet of all values, since you don't necessarily know what was entered the last time you used it. The key to using the CF worksheet is to get in the habit of entering a numeric value and pressing Enter to place it in the worksheet, and the down arrow to move to the next cell. We didn't have to do this with the TVM key, so this is a change. Think of the worksheet as a column of values. You can use the up and down arrows to review your entries if needed. Once you enter CF0, you'll be successively presented with C01, 02, and F01, 02, etc., which allows you to enter the frequency when several sequential cash flows are the same amount. When you've entered all the cash flows, press NPV. You'll be asked to enter the discount rate. It's a whole number. Enter a number, press Enter, and the down arrow, and NPV will be displayed. Press Compute, and you'll get your answer. If you doubt you've entered the numbers correctly, you can always review them. Remember, they stay in the cash flow worksheet until you overlay them or clear them out. Please be sure you're comfortable using the cash flow worksheet. Enter these values and be sure you can arrive at the answer shown. We'll be using the cash flow worksheet quite a bit, especially in the later chapters in this course. So you need to be sure you're comfortable with it now so it won't be a problem when we come back to it. This is demonstrated in the A3 video tutorial. In Excel, there's an NPV function, but it has some differences from your calculator and one peculiarity. First, in the NPV function, as in all Excel functions, the interest rate is entered as a decimal. Second, there's no ability to shortcut on repetitive cash flows. Each cash flow has to be entered in a cell of its own. It can be horizontal or vertical. There's no frequency counter. The peculiarity. Apparently, when Excel was first designed, the NPV function was defined erroneously. After all these iterations of Excel, it can be changed now, so we just have to adjust for it. When you enter a range of cells in the NPV function, Excel assumes the first cell contains cash flow 1, not cash flow 0, so it discounts it. CF0 has to be handled outside the NPV function if there is a CF0 value, which there's not in this example. We'll cover this more fully in Chapter 10 and in the video tutorials that go with that chapter. This concludes Part B of Chapter 4. From here, in Part C, we'll cover interest rates and loan amortizations.